Alright guys, welcome back to chapter 2 of our scripting and automation class. Today we're going to be talking about some of the basics of electronics. So this class revolves around a lot of microelectronics, including Internet of Things electronics. And so there are some concepts that we need to understand before we get into understanding how we're going to control this hardware. Now, we all know that electricity can be dangerous, and so with microelectronics, they're a lot more sensitive to electricity than some of the larger electronics. Now, this set of electricity is going to be such a small amount that it's not going to do anything to us as humans, but it could easily fry, an LED or a button or one of the other electronics on our control boards. And so we have to understand a little bit about it before we start programming. All right. So, the first thing I want to talk about is definitely going to be that hardware side of our automation toolkit. So in the introduction side, you will notice that we have a section called gear, and in our gear section it tells us exactly what kind of hardware we're going to be utilizing throughout this chapter. So as we go through there, we need to understand those building blocks. There are going to be some of these fundamental concepts of how things work, and it's all about Ohm's law, and so we're going to see how those relate to each other. So our first analogy that we're going to use to help you put this together is going to be water flowing through pipes. This is something that we like to use when we're trying to talk about voltage and resistance. And so that way it'll help you understand how it really is working with a piece of wire and why, if you do things incorrectly, that it can actually destroy your electronics. So the first part of our three-part concept is going to be the voltage. Most of us have seen voltage in the past. We've used AA batteries, AAA batteries, 9-volt batteries, and we always rate them like that. 9-volt batteries, you always hear it that way. And so we always rate it based on the voltage itself. A AA battery, for instance, is only a 1.5 volt, not very much, but the outlet in your house could be 110 volt or even more if necessary. So voltage itself is the difference between 2 points. It is the push or the pressure. So when we think about our water pipes and voltage, think about it, how hard is that water pushing through the pipe? That is voltage. Okay? Higher pressure will push more forcefully, while lower pressure will push slower and less forcefully. We measure this in volts, and you'll see it with a V in most of the diagrams throughout this course. The next one in there is going to be flow. This is current. So current is normally rated in amps. You'll see it either as an I or as an A. It all depends on which we're looking at. But what we're looking for here is how much charge is moving through. So the way that I like to look at this is flow rate. Think about gallons per minute. So if we have a ton of water sitting in a water tank behind us, and there's a lot of pressure behind it, there's going to be a lot of voltage. But also, if it comes out very fast, the flow, that's going to be the gallons, okay? How much of that voltage, the water level that we have, is going to be pushed through there? How fast will it come through? And we measure this in amps, and often in this class, we're going to be using milliamps, okay? Milliamps is a smaller version of amps, and it is what we rate things in because we're dealing with such a small amount of electricity. Now we have the opposition. So something that's going to prevent the water from flowing through the pipe or something in that nature will restrict the flow is going to be a resistor or resistance. We measure this in ohms. So it may actually say a 200 ohms resistor. And you'll see that throughout even today's lab. Resistance itself is the narrowing or an obstruction in the pipe that will restrict the water flow. And we're doing the same with electricity. If I have 5 volts of electricity trying to come through, and I don't want 5 volts, maybe I want 3 volts. What I will do is add resistance to it, so that way only 3 volts of electricity comes out the pipe, comes down the wire. Okay. And so when we pull this all together, we get what's called Ohm's law. Ohm's law states that there is a relationship between these three attributes, and they are proportional to each other. So we have voltage equals the current times the resistance. So we can do a little bit of math and we can formulate this in any way, shape, form. So if we know the voltage and we know the resistance, we can always come up with the current. If we know two of the three of anything in this equation, we can always come up with the third item. Now, for this course, I will always give you which resistor to use, okay? And the main reason for it is you need to understand that it exists, that Ohm's law is there, but you're not an electrical engineer. You won't be doing this on the day-to-day. But just know that, hey, if I'm replacing a resistor on a motherboard, I probably should replace it with the same resistor. Okay? If I change the resistance on the motherboard, then it's going to change the electricity on the board, and maybe I'll burn out some other form of electronics. I like to call it the magic blue smoke. Okay? We don't want to let out the magic blue smoke because that makes us have to buy yet more hardware. All right, so an LED, for instance. So today we're going to be doing an LED circuit. An LED requires a very small amount of electricity. The LEDs that we're going to be using is normally about 1.3 volts. Okay. Now we're going to connect it up to a 5-volt circuit. So what we need to do is we have 5 volts. We need 1.3 volts. What we're going to do is add resistance. So adding a resistor in the circuit will allow us to drop that 5 volts to the proper voltage that the LED needs to make sure that it's safe and it doesn't burn out. Okay, and so the resistor that we're going to be using today is most likely going to be the 220 ohms resistor. And we want the resistor in our circuit to ensure that, well, that we don't burn out the LED. Okay. So that is Ohm's law. And before I go on to the next section is going to be all about analog and digital signals. And we'll actually talk about signal transfer quite often in this class because depending on what we're dealing with, depends if we're going to be dealing with an analog or a digital signal. The signal voltage changes depending on whether or not it's analog or digital. For example, if you have a room with a dimmer switch and you want to turn the light on, well, is it on or off, 1 or a 0? That is the digital way of a light working. It's either on or it's off. You can't control it. But if we add that dimmer switch in there, we can turn it on, but we can turn it on at 50%. That's when we start dealing with analog. Analog isn't just on or off. We're dealing with a wave instead of just being on or an off, a 0 or a 1. So we're not dealing with absolute values when we're dealing with analog. And a lot of times what you're going to see here is we're going to see it be represented as like a sine curve. For those who haven't seen a sine curve, refer to the book material here and we can actually see what those curves look like. So our analog signal, it can change continuously over time. It can be 0, it can be 0.1, it can be 0.2, to infinite numbers of possibilities between its minimum and its maximum. And as I like to say, that's my analogy, the dimmer switch of a light bulb. If you can dim it, we're talking about an analog signal. Now, when we're talking about analog signals themselves, the devices that we're using, the Arduino boards, the ESP32 boards, they don't know how to handle analog signal. So they use what they call an ADC, an analog to digital converter. It will read in an analog signal and convert it to a digital signal. Now this analog signal will always come in between 0 and 1023. That's the value that it will come in as. So if we have a dimmer that's going to be at 50%, well, half of 1023 would probably be about 512, and so that's what we will read on the Arduino. 512 would equal to 50% of the analog voltage that we want to give it. And if this doesn't make sense, as we go through this course a little bit more, it will start making more sense. Now, as I said with digital, these are discrete, predefined levels. They are binary, zeros or 1, highs or low. And as I said, my analogy here is the standard light switch. Is it on or is it off? If it's off, it's a 0. If it's on, it's a 1. Okay? Now, the reason why this matters is because when we go from hardware to software, we're going to need to be able to read this information. Whether or not we're controlling an LED or if we're controlling, reading in an analog signal, like a thermostat. In order for a thermostat to be able to tell us what temperature it is in the room, it has to be able to tell us a value. And the value is always going to be an analog for a thermostat. It's going to be 0 to 1023. That's why they have to be calibrated. Once they're calibrated, then they can tell us the temperature with pretty good precision. Now, there are other things out there that we're going to control, like motors and servo motors, or we're going to read some sensors in from like motion sensors, or as I said, controlling an LED, or maybe we're going to watch for a button. Does that button get pressed or not? And so what we're going to use is digital or analog read and digital read in order to read these signals. Now, before you start building your first circuit, what you're going to be always given is what's called a schematic. And this is a symbolic representation of the electronic circuit. It helps us understand how a circuit is built. Now, you're going to see things that are going to show you logical connections. They're going to give you different signals depending on what type of device it is. And the reason why we do this is it's a universal language. No longer do I need to worry about if you're speaking English or Mandarin or Italian. It doesn't matter, because if we all use symbols, then any of us can read the schematic itself and build the same exact circuit. We will be using breadboards in this class. This will help us build temporary circuits quickly without destroying our current hardware. Now, if we had a temporary circuit we wanted to make a permanent circuit, that's when we would actually bring in soldering boards. This is when we would bring in a soldering kit to make sure that, hey, if I'm going to take this temporary circuit, I can turn it into a permanent circuit by soldering the components into place where they won't move again. But we're going to be using breadboards here, and it's called a solderless breadboard for a reason. And in the Appendix A of this book, you'll notice that there is a pretty good section that shows you pictures of breadboards and shows you the schematics of how the trails are actually put together. So initially, you're going to find the terminal strips. The terminal strips are the horizontal row on the side of your breadboard. The horizontal rows are normally all the way on the edges, and it's normally going to be a positive and a negative signal. Okay, everything we're doing here with is a DC signal, or otherwise known as a direct current signal. And so in order for it to work, we need to complete the circuit. We need to have it from positive on the battery all the way to the negative of the battery, and that could be to our circuit boards. And so you'll notice that those two lines they're adjacent, and they are going to provide power all the way down the row. And so the way that the breadboards work is they will be connected horizontally to it. And so definitely go look at that schematic at the end of the book so you can see exactly which ports on the breadboards are connected and which ones are not. So we already talked about the power rails. Now, the big thing here is we like to color code our wires. Like, for instance, I like to use red for my power, black for ground, and it helps me understand what wire goes for what. So you'll notice in your kits that you'll have colors in your kit, and you can use them for different reasons. And there's a whole bunch of different colors. There's not a right or wrong wire to use. Every wire is the same. They're just color-coded to make debugging easier and to make sure that you understand where things are going. Now, after you're done building your circuit, what I like to do is do a double check. I double check every connection on my soldering board, my breadboard, and make sure that everything's connected well, because we want to make sure there's not any loose wires before we put power onto the connections. Now, before you go through this chapter, let's go through a couple of the common components that we're going to be utilizing throughout this course. The first one is going to be that resistor. And remember, anytime we want to resist the amount of power, instead of putting 5 volts to a line, we're going to use a resistor. And remember, those are measured in ohms to be able to figure out, well, I don't need 5 volts for my LED. I want 1.3 volts. And I get the same question every year about, well, how do I know what hardware takes what voltage? And there really is only one answer. The answer is, well, go look at the manufacturing spec. The manufacturer will provide you with a spec to say normal operating temperatures or normal operating voltage ranges. They'll tell you everything you need to know. Now, and I do say a range because most of these devices can operate within a range, maybe 1.1 volt to 1.3 volt. They're not always going to be a hard-coded as in you need 5 volts on the dot or this is going to break. Okay, there's normally a range. So that first one is going to be resistors. It doesn't matter how you connect them up in your circuit. They just need to exist, okay? And that's what's called not polarized. In other words, it doesn't matter which direction you put them in your circuit. Now, on the other hand, we have what's called an LED. Most of us know what an LED is. It's a light-emitting diode. It's basically a light, right? And that's what it is. They can come in a whole bunch of different colors. There could be multiple things. Most of the LEDs that we're going to work with in this class are going to be the 2-wire LEDs. And a 2-wire LED is polarized. It needs to be correctly set up. And so you'll notice that your LEDs have a longer leg. One leg is longer than the other. The longer leg always goes towards the positive side. So if power is being applied to your LED from a Arduino or an ESP32 or a battery, you always make sure that the long leg is towards that section. The reason for this is called a diode. A diode only allows power to go through it one way. If you flip this backwards, the LED probably won't light up. Okay? It won't damage the LED, but it will just not light up. You'll expect it to light up and it just won't. Now remember, LEDs are going to have a operating voltage, so make sure that you're using the proper resistor when you're using them. So limiting current resistor, that's what I wanted to say. We don't want to destroy it. Once an LED is destroyed, it's just garbage, okay? There's nothing we can do about it. Now you're going to be using buttons in this class quite a bit, and this is just a digital input for your project. Did you press it? Did you not press it? Okay, it's a momentary switch. You can use the button to say if detected, if button equals 1, then it's pressed. If button equals 0, it's not pressed. And we'll work through that logic when we get there in our labs. We can use things called potentiometers. Potentiometers is just a fancy term for just being a variable resistor. Now you use potentiometers every day. If you've used a volume knob in your car, the volume knob in your car is a potentiometer. What it does is it controls the resistance through a wire so that way it can turn up or down the volume of your stereo. Now, when we adjust the voltage within your circuit, you could use this for LED brightness. You could use this for a whole bunch of different things, including, well, maybe I want the LED to flash, but I want it to flash based off of where the potentiometer is set. And remember, this is going to be an analog input, and so our analogs are always going to read between 0 and 1023. All right, so today we're going to build a very simple circuit, and what we're going to do is use a blinking LED. Now, I understand that some of this stuff might still feel a little foreign to you, and it's going to be okay. So just go through the motions, grab the code off of the lab, put it in your code, and this is what we're going to do. So there are 2 parts to this lab. The first part of the lab was just installing software. If you've already had that completed, great. You do need to have Arduino at least installed on your computer for this lab to work, okay? Because we will be using the Arduino Unos today to just build a very basic blinking LED circuit. So when you're going through the code, you're going to actually see a couple different functions. And as I said, you're not really needing to understand this 100% today. This is just getting you familiar with utilizing hardware. And so the code itself, we'll keep digging through as we go. But the first 3 lines here, we have to configure the LED pin to be an output pin because we have what's called an output device. We're going to put signal out to the device. Then we're going to turn it on by telling it to go to high, because an LED here, we're just going to do digital. Remember, it's going to be on or off, 0 or 1, true or false, high or low. And then lastly, we can use delays to help pause the program. So the program is going to run forever, and we can change our delay value to determine how fast do we want our program to blink. Now, if your LED is not lighting up, make sure that you check all the wiring that you have in your circuit. Make sure your LED is faced the correct way. If it's backwards, it just won't work. Try flipping it around. Check your code. Did you make sure you plug the wire into the right pin number? And what that means is on the board, you'll notice there's a number next to it. When I say plug your wire into pin 6, look for the pin that says 6 next to it and plug the wire into there. And then lastly, did you actually put the code onto the board itself? Did you pick the correct board in Arduino? And if you haven't done this before, in the install settings in the appendix, it will walk you through on how to install Arduino Uno and Arduino IDE. Okay. All right, so we just talked about a few things. We talked about Ohm's law and the relationship between voltage, current, resistance. We talked about the difference between analog and digital signals. We talked about reading a schematic. We don't really do too much of this yet, but we will get lots of practice reading schematics. And then we are going to build a temporary circuit on a breadboard. That one is going to give us a blinking program. So go through the rest of this and then keep practicing through it and keep going on with your Wyoming Cyber Range learning. I'll see you for Chapter 3.